I have an agent running that opens a browser, gathers the latest top tech stories, saves them to a persistent file system, and then delivers me a message every day when it's done. And no, I'm not using OpenClaw. I didn't write my own API. I didn't have to build an entire orchestration layer. I didn't even have to set up containers or wire up storage. The whole agent loop was built with a config file and a system prompt. That's the manage harness in AgentCore. Let me show you how it works. Every agent has three core pieces: an LLM that reasons and decides what to do, tools that let it take action, and a system prompt that gives it instructions. User input goes in, the LLM calls tools, reads the results, loops until it has an answer, and then it sends the output back. Frameworks like Strands, LangGraph, Crew AI handle that loop for you. But running that loop in production, that's a different problem. Putting everything together can be tricky. You'll probably need compute, a sandbox, containers, storage, memory, auth, and observability. With the new manage harness in Amazon Bedrock AgentCore, it replaces all of that with the config. It runs the loop, you define the agent. The manage harness has three steps. You define an agent via config, deploy, invoke, then you're done. Let's dig into what that means in practice. When you create a harness, you get an isolated micro VM for each session. Each one has its own shell and file system. Memory is enabled by default. It is cross-session and scoped by user. Persistent storage is at /mount/data, and it survives VM restarts. You can swap models, tools, or the system prompt per API call without redeploying. You can run shell commands directly on the VM with the --exec flag, which is nice because it doesn't cost any additional tokens. If you need specific runtimes, you can bring your own Docker image. The harness also supports skills, which are bundles of files and instructions that can give the agent domain-specific capabilities like generating spreadsheets or PDFs. The harness also connects to every other AgentCore service: browser for web scraping, code interpreter for sandboxing code, gateway for securing API access, as well as memory, observability, and identity. This can all be added through the config. You add a tool to the harness.json and it's wired up on the next deploy. So here's what we're building today. Event Bridge fires every hour, triggers the Lambda calls the harness. Inside the harness, the agent opens Hacker News in a managed browser. It extracts stories, then it fetches Reddit via RSS, saves a snapshot to /mount/data every 6th run. It reads all the snapshots, identifies trends, and writes a digest. And you can chat with it anytime through the CLI. Let's try this out on the command line. I'm going to use the AgentCore CLI. To install the AgentCore CLI, I can run npm I tacg AWS/AgentCore at preview. And this will install the AgentCore CLI that we need to use. Now I already have it installed. Once it's installed, you can do AgentCore -- version, and you can make sure you have the latest one. And I also have AWS CLI installed, so I have all my credentials saved locally. If you don't already have that done, you can always check some of the links in the description to get the credentials on your command line. After you have the AgentCore preview version installed as of this recording, then you can go ahead and create your harness. So I'm just going to copy and paste this from my other screen. I'm just going to run AgentCore create with the name, in this case, that the Pulse, the provider, and the status storage. In this case, I'm going to call it the Pulse 1. And what this is saying is go ahead and create a new harness with this name as the project name, and then we can have multiple harnesses in that one project. And it's going to use Bedrock, and it's going to use this /mount/data to have data that will be persisted through every single time as you open up the session. All right, so it looks like it finished. It created a few folders for us, and it even gives us some nice instructions to deploy if we'd like. However, I like to add a few other things. I'm just going to go into the Pulse 1 folder, and you can see some of the information in here. Is if I do AgentCore add, I get this nice terminal UI of choices. You can also do the same thing with AgentCore create if you didn't want to use all the different arguments. This might be changing in the future as we update the preview, but you can add harnesses and agents and all that other stuff. In this case, we want to go ahead and add a tool for it. So by the way, if we look inside the app folder, you can see the Pulse 1. Here is essentially the harness it created for us by default. And so now we can go ahead and run this command here. So I'm going to add a tool, and you can add in MCP's tools, you can add in skills. In this case, I'm just going to add a tool in for the pulse. And I'm going to add in something called the AgentCore browser. And as you saw earlier in the video, you have access to any of the AgentCore, different parts of AgentCore, including identity, the browser, and all the other things that it comes with. Okay, you can see it went ahead and did this. And the next thing we need to do is add in that system prompt. So you can actually just go into the system prompt.md markdown file and change it here. And you can see here it defaults as you are in a helpful assistant. I have one handy that I'm going to copy and paste here. It's pretty involved. It's basically saying, hey, we're going to create something called a Pulse, which is an AI research agent. It's going to use that AgentCore browser to actually go to Hacker News and grab the top 30 stories. It's going to use the Reddit RSS to use some curl commands to grab all the information out. And it's going to create a snapshot every single hour. And then every 6 hours, it's going to, instead of using the snapshot, it's going to create a digest that we can use and grab and have it being sent later on. So that's it. We can also go into the harness JSON file. You can see some of the configurations here. This is where I can change the model. It's really nice. You can also, as you invoke it, you can change the model in system prompt as well. So you can have it be very dynamic. So I think this looks good for now. I'm just going to run the AgentCore deploy command, and this is going to deploy it. Now this can take up to 3 to 5 minutes because it also creates an AgentCore memory, which takes a few extra minutes. It uses CDK in the background for some of the IAM roles and permissions. So we'll just give this a minute. Okay, it completed, and now I can test it out. I want to create a session. So I'm going to use this session ID, which I'm just using UID gen. It has to be 33 characters at least. So now I have this nice session ID, and then I can run this AgentCore invoke. I'm going to pass some parameters to it. First, the pulse 1. The session ID, I'm just going to call, I'm going to pass in that session ID variable I just created. The actor ID scheduler, I'm going to pass this in hourly run collect AIML stories and save the snapshot. And it should go ahead and talk to our micro VM. And you can see it running its different tools, the browser, the shell. It's using this session, and I'm going to be using this session throughout this video. That way I can look at what it's doing. Looks like it got the Reddit data. It's using the browser tool to actually open up the browser. You can also save the browser as snapshots if you like. Looks like it had a problem the first time, but looks like the second time, looks like it got it. So we'll just take a second. It says excellent HN data collected. Now let's close the browser and save everything to a JSON snapshot. And it should save it into this mount data. So that way we can see it there and it'll persist for every single session. All right, so you can even see everything it did. It got the top 30 stories, and here's the whole markdown that it created. All right, let's just double check to make sure it is in where it's supposed to be. So I can run this command here, which will go ahead and run this exec command. So this is nice. This doesn't take up tokens. It's essentially just running commands on the file system. In this case, just a list command of the mount data runs folder. So let's see what it looks like in here. All right, so here it is. So we could see that it actually, in UTC time here, that it saved the JSON file itself. So this is really neat. Let's take a look at this a little bit more. So the agent works, but I don't want to run it manually every hour. I want EventBridge to trigger it on a schedule. For that, I need a Lambda. Now here's the Lambda. Let me walk through the most important part. This is the core of it. Invoke harness command. One API call. You pass the harness ARN, a session ID, and an actor ID, and the prompt. That's it. The session ID is the same one we've been using. Same ID means that we have the same /mount/data. That's how data accumulates across hourly runs. The actor ID scopes memory. The schedule gets its own memory namespace. If I add messaging later, each user gets their own. The prompt changes based on the hour. If the UTC hour is divisible by 6, it's a summary run. Otherwise, it's a collection run. The CDK stack is pretty straightforward. Event bridge schedule fires every hour, and the Lambda has IAM permissions to invoke the harness. Now I want this digest to show up on my phone. When the summary runs, this Lambda should post it to Telegram. I added a secrets manager client to fetch the bot token. The send to Telegram function handles Telegram's 4096 character limit by chunking the text. After the harness responds, it's a summary run. It sends the digest. The bot token lives in Secrets Manager, not in an environmental variable. The CDK stat grants the Lambda read access to the secret. Now let me deploy everything and show you the full flow. Okay, so it's deployed. So now I'm going to talk to the Lambda function and actually send a message to it rather than waiting every half hour. So this will go ahead and actually invoke the Lambda function, which then should automatically send over the data to Telegram. And as we wait, we can see we have nothing in Telegram right now, so we're just waiting for it to run. Here it is. I'll start by checking what snapshots are available that generate summaries digest. So here is the digest and summary of what it has, which is great. We can also go back to Kiro in our terminal, and it finished. So you can see it sent the digest true. Everything worked as we expected. So that's the manage harness. You define the agent config, deploy it, and invoke it. The harness handles the loop, the compute, the storage, the memory, the observability. You focus on what you want the agent to actually do. Okay, check out the links in the description to find out more information. Thanks for watching.